Students, in this video we are going to learn about reflexive relation. Reflexive relation, a relation R on a set A is called reflexive relation if A is related to A for every A belongs to A. That is, A comma A belongs to R for every A belongs to set A. So I repeat it again, reflexive relation, a relation R on a set A is called reflexive if A is related to itself, that is A, for every A belongs to A. That is, if A comma set of ordered pairs A comma A belongs to R for every A belongs to A. You will have doubt in your mind what is the difference between reflexive relation and identity relation, that I will explain later. Now we will understand what is the meaning of reflexive relation with the help of an example. Let A is a set which contains the elements 1, 2, 3. Define the relations R1, R2 and R3 on A as 1, 1, 2, 1, 2, 2, 3, 1, 3, 2, 3, 3. Check like this, we have R2 and R1. Now we need to check whether R1, R2, R3 are reflexive or not. As per the definition, every element of set A, that is every element in the first set, must be related to itself. But here it is every element must be related to only to itself. A comma 1 means when we give every element of set A must be related to itself only. 1 can be compared with only 1 and 2 is related to only 2, 3 is related to 3. Every element in set A is related to itself only, but that condition is not present. That only, the word is missing here. That is the main difference between reflexive relation and identity relation. With this example you will have clear idea. Every element of set A must be related to itself. If you consider this 1, 1, the first element of A is related to itself, and then second element 2 is related to itself. The third element of this set is related to itself. Apart from this 1, 1, 2, 2, 3, 3, the first element can be related to other elements, or second 2 can be related with other elements, 3 can be related to other elements. Here 2 is connected to 1 here, and then if you observe these two elements, this 3 is connected to 1 and this 3 is again connected to 2. Here, apart from identity elements, that is 1, 1, 2, 2, 3, 3, the numbers can produce other value, can be related to other values also, like 2, 1, 3, 1, 3, 2. It can be called as reflexive relation. If it is an identity function, means definitely 1 can be related to only 1, the number itself. This 1 cannot be related to any other elements. 2 can be connected to only the number itself. 3 can be connected to only the number itself. The each and every element of A should be related to itself only. It cannot be related to any other element. But here in reflexive function, every element should be related to itself. After that, the number, every element of set A can be related to other elements also. But here it is not allowed. That is, in identity function it is not allowed. That is the main difference between reflexive relation and identity relation. You can understand this concept in another way also. We know that the range contains set of all outputs and codomain contains a set of all outputs and some extra elements. But codomain can be equal to range also, but codomain may contain other than set of all outputs. Similarly, reflexive relation can contain identity relation. Apart from that, it can contain other elements also. That is the main difference between reflexive relation and identity relation. Please understand this concept very clearly, and then we will check whether R2 is the reflexive relation or not. Each and every element of set A should be a part of it. 1 is related to 2 and 2 is not related to any other elements and 3 is not related to any other elements. Hence, the R2 is not the part of, is not satisfying the reflexive relation concept, hence R2 is not reflexive or reflexive relation on set A. Now we will take R3. Here 1 is related to 1, but as per the definition of reflexive, every element of A should be related to itself. Here only 1 is related, 2 is not related to anything, 3 is not related to the number itself. Hence this is not the reflective relation. You observe this, since 2 comma 2 is not does not belong to R3, hence R3 is not reflexive relation on set A. I hope you understand this reflexive relation concept as well as identity relation concept. Now we will make note of this important information. Identity and universal relations are reflexive. Always identity is a reflexive relation and universal relation itself is a reflexive relation, but empty relation is not reflexive. Please make a note of it. Empty relation is not reflexive, but identity and universal relations are reflexive. We can get one more information from this. This reflexive relation can be identity relation, but identity relation need not be, understand the word need not be, the identity relation need not be reflexive relation. Now we move on to the next concept, that is symmetric relation. Symmetric relation means a relation R on set A is called a symmetric relation if A is related to B. Implies that B is related to A for every A comma B belongs to A. That is, if A comma B belongs to R means definitely B comma A must be present in the same set R for every A comma B belongs to R. That means the inverse order of this set. If A comma B is part of this relation means definitely its inverse, that is first coordinate becomes second coordinate becomes first coordinate. That element also must be the part of this relation. You can understand this clearly when we see some example problems. Now we will look at it. Let A is a set which contains 1, 2, 3 and define relations R1, R2 and R3 on A as this. Check whether R1, R2, R3 are symmetric or not. Now set A is there which is 1, 2, 3. As per the definition, if A is related to B implies means definitely B is related to R for every A comma B belongs to set A. So every element of set A should be related. Hence here 1 is related to 1, this 2 is related to 2 and then this 3 is not related